Alrighty, everybody, welcome to Motion Matching First Look Round 2. The reason this is Round 2 is we already did a Round 1 First Look, and since then we have discovered and learned a bunch of new things that warranted pulling down the original video and redoing the whole thing from scratch. So today we are going to be taking a look at motion matching. So right now, motion matching is all of the rage. Everybody's very excited about what motion matching is. It looks cool. It seems like it's easy. You just drop it in and your character just looks awesome. So the way it works is there is a giant database of animations. And in that, basically what happens is all those animations gets coalesced and tagged and kind of organized. And then what you do is you give the system information about which way your character is moving, turning, velocities. There's all kinds of different parameters you can use. And then what happens is, depending on which parameters you use and which joints, etc. you're tracking, your database will give you back the best pose for what it is that should be playing on your character at any given moment. Now, what this means though is that the data sets, in order for it to have a high fidelity, get quite large. Now, there is a sample project that is coming according to Epic in June of 24. It's going to be awesome to be able to take a look at that and see what kind of best practices and everything we can learn from that. Right now, motion matching is technically experimental, but that doesn't mean there isn't a lot of cool stuff. So a couple more things to touch on before we kick off. One, because motion matching, generally speaking, requires a bunch of data assets, it is probably there's a bit of a slippery slope here, okay? It's probably a lot of work to generate those assets. So if without the ability to generate all those assets, if everybody starts using this same motion matching tutorial, everybody's games are going to start looking the same. So don't do that. Make your games cool, make them unique, make them fun, make them have style, all right? Don't forget that. Do use motion matching as a tool to help get your prototypes going, to help prove out new characters, all those kinds of things. And then obviously, as the databases grow and expand and we can find cool ways to vary them, great. But don't lose the art, people, please. Second thing is a huge shout out to Andre. We had an amazing multi-hour session where a bunch of our community was hanging out in Discord, and Andre was kind enough to share a bunch of his insights and learnings and point out some of the mistakes that I had made, or more efficient ways of doing things from the original First Look motion matching video. I'm trying to coalesce all that here today. So with that, let's get started on our motion matching First Look Round 2. We are going to be doing this 3 different ways, okay? So I'm going to show you how to set up motion matching. We're going to do it just a plain motion matching method. Then we're going to use a animation state machine method, and then we're finally going to do the exact same thing again with a chooser, so that you can see all 3 different methods, and then between the 3 figure out what works best for your project and move from there. So with all that monster intro, let's hop in and take a look at getting set up for motion matching. All right, so here we are in Unreal. There's a couple things that we do need to set up. This is a default third-person template file. I'll just go ahead and increase the font size for you all to be able to read. And we are using 5.41, but in general, if you want to do motion matching with the new stuff, you need at least version 5.4. Now, if you watched the previous first look at motion matching, there is one change. We're actually adding another plugin in this setup. So make sure you get the chooser plugin in order to basically be able to facilitate the third way that we're going to be setting up the motion matching. So with that, let's get started. First, we need to load some plugins. So let's go to our window and we will go to Edit, Plugins. And the 3 plugins that we want our pose search. So we'll go ahead and check that. Then we also need our trajectory. So we'll go ahead and check that. And it's experimental. We know we're excited about the experiments. And then we will go ahead and look for the chooser. This was the change since the last version, one of the several changes. And then now that we have all those going, we can go ahead and choose restart now. So that's going to restart. And while that's restarting, you'll notice that I have a Lyra project here in the background. We do need some animations in order for us to work with motion matching. And so rather than creating a whole bunch of animations and spending all that time, we're actually going to migrate all of the Lyra assets over. So to do that, also as part of our project setup, we're going to go to characters, we'll choose heroes, mannequin, and let's see here, we have animations, locomotion, and we're going to use the unarmed set. And in here, I'm just going to filter for animation sequence. And we're just going to take them all. So I'm going to select them all, and then I'm going to right click, and I'm going to choose asset actions and migrate. Now, there's a bunch of stuff that we don't need. I don't need the modifiers, for example. I don't need the notifies. I want to keep this fairly clean. We'll keep all the animations. I don't need any of the materials because we've already got materials. We already have meshes. We're going to be stealing or reusing the skeleton in our already existing project. So I can basically uncheck all of these effects, all of that, and there you have it. So that's everything that we need. The way the migration works is you go ahead and click OK, and then you have to find your project. You'll notice that we are on motion matching 3. We have done this so many times. All right, so here we go. We go to motion matching 3, we'll choose content, select the folder, and that's going to go ahead and migrate all those packages over for us. Now, once we have those migrated over, I'm going to go ahead and close Lyra just to save some resources, and these will show up in our folder over here in our project under locomotion unarmed. Now what I want to do is, technically if I open any of these, they're not going to play properly because this skeleton, remember we did not bring over the skeleton, so it does not know how to play itself. So I'm going to just quickly update the skeleton by right clicking and choosing replace skeleton, and in this case I am going to select the SK mannequin skeleton, this one, not UE4. Yeah, that's correct. Okay, so go ahead and click OK, and once it does that, it will go ahead and it will update all of our stuff so it actually shows a proper visual. And then what I like to do is I like to at least open one of these and just make sure it's actually working. So okay, so at this point we've loaded our plugins, we've got our animations to work with. Let me just go ahead and save all of our animations. Frequently and often we're using an experimental feature. And let's get a couple more things set up. So in order for us to, let's go ahead and into our tutorial folder and let's talk a little bit about what we're going to be building here. So there's 3 or 4-ish major parts to motion matching. All right, basically the way that motion matching works is it is a database of animations, and they basically, all your animations get dumped into a database, and they all get tracked on a per joint velocity, rotation, all kinds of different bases. And then what we can do is we can use some kind of metric to choose the best animation pose based on that metric. So what I mean by that is if you have a character that's running forward really fast and you're tracking the feet and the hips, for example, and you say database, give me the best pose for the character moving this fast and in this position, and it will go through and say, this is the best pose, and give that to you. It's kind of a loose version of the way this works. So one of the things that we need is a database. However, if we try to create, if we come up here and we try to create our pose search database, you'll notice these are our 3 options. If I try to create a pose search database, you'll notice there's no config. So what we need to do is we need to define the rules or the schema that allow us to talk to the database. So that's the first thing we're going to create. So if we go ahead and type in here pose, I'm going to create a pose search schema. And the pose search schema needs to know which skeleton we're working with. And I'm going to call this my PSS pose search schema. This is going to be Manny. Okay. And when we open this up, it's worth just a quick little walkthrough. And what we've got here is, as I've described, this is the rule set of how we are going to select the right poses from our database. So our skeletons, pretty straightforward. We have that here. We have our channels. If we shift click the channel, it'll just open them all up for us. Now, you can see what it's using to choose the pose here. We have all kinds of measures. We have position X, position XY, we have velocity and position, etc., etc. And you can also see which sampled bones are being used currently. Right now we're using foot left and foot right. So this is kind of the rule system that is used to look up information in the database. According to the docs and in general, these basic rules will work really well, especially for the purposes of this demo in a lot of the cases, but you can come in here and you can play with a bunch of these to figure out the best match for you. So we now have our pose search schema. Now we can create our pose search database. So up here, we'll go ahead and choose pose search and we'll choose database. And when we do that, it is going to ask us for a schema. This is going to be our pose search database. I'm going to call this Manny all, because this first method that we're going to be doing is the kitchen sink. We're throwing it all in. It's going to be all motion matching all the time, and we're going to see how it looks. That's the plan. All right, so what does this pose search database look like? Well, when we open this up, this is the really cool stuff. So over here on the left, top left, these are all of our database assets that have been put into this database. Over on the right is our viewer, and then we have, various settings and information that we can set for all these things. Now, to add animations to this database, we could just go ahead and click add and add them one at a time, but that would take forever. So what I am going to do is I am going to go ahead and use the content drawer. I'm going to go down to our unarmed. And what I'm going to do is I'm going to do a quick search in here. I only want the underbar. So let's take all of these. And actually I want all of them, but not crouch. And so I'm using a exclamation point. So I'm getting everything but crouch. So let's take all of these and drop these in. Okay, and now we get to have a lot of fun. So let's get rid of our content drawer. One of the cool things about the way this works is when these animations are set up in here, you can take a look and you can just click. For the ones you click, you'll see it kind of just playing and what they look like over here in our visualizer. Now the cool thing is this visualizer is kind of helping us see what the visual representation of the current schema looks like. So you can see we have this trajectory and then we have these green vectors on each of our feet, right? Remember, we are tracking the bones left and right foot. So this gives us a visual idea of what is going to be used for the pose selection. Now, a couple other things that are important. You'll notice over here on the left, there's basically the looping, whether or not it's looping, and we also have root motion enabled. Now, generally speaking, everything I've read, everything I've tested, you want root motion enabled on all of these, so we're going to do some property editing. And one other thing that's worth mentioning is I've seen a lot of tutorials where they turn the looping on. I've actually had great success not turning it on, but I would go ahead and try both ways. But for today, we're not going to turn on looping for any of the animations. So first things first, let's at least do a quick update to all of these. We're going to use a property matrix. We're still kind of in setup at this point. So if we right click on these, we choose asset actions and we do a edit selection in property matrix. What I want to do over here in the details for root motion, you'll notice that this is a dash. That means some of them it's on, some of them it's off. So I'm going to turn them all off and then turn them all back on. And then I'll go ahead and click save, Control S to save those. And then when we come back to our pose search database, you'll notice that these have all now been set up to have our enabled root motion. Now, there's a couple things that we're not going to use today. We're not going to use our idle breaks. We are going to use our idle readies. We'll keep all of our jogs. We'll keep all of our walks. We're not going to use our turns, so I'm just going to select those. And this is one of the cool things about using motion matching. You can just add stuff in and take it out super quick. So we're not going to use our turns. So we have our walks, our jogs, our starts. We do not need our jumps either. So let's get rid of our jumps as well for the purpose of this demo. Okay, so we basically have everything we need in our database, and just for fun, I just think it's so cool to see the characters doing that all at once. Real-time stuff is fun. And we've got it. Now, we've basically got our database set up now. Okay, so we've got our database, we've got our pose search schema. We do need to, let's talk real briefly about this other item, this pose search normalization set. So basically, from what I've seen in the code and what I've seen in the documentation I can find, basically what this is used for is this is used to normalize the searches across different databases. So that if you have two databases with very different types of movement, like really fast runs and an idle, it is meant to be able to help normalize that. So as you're looking between them, you get reasonable lookups. That's from everything I've read so far. We will get a more definitive definition and use cases as we go forward, and maybe even do a separate video on that. But the good thing to know is this is totally optional, so we're not even going to be using that today. Now, the last bit of setup that we need to do before we actually start connecting everything in and actually building our motion matching is we do need to make a change in our third-person character. So our third-person character right now, it's the standard third-person character. I do want to change this. I'm going to change this to Manny. And I'm going to briefly change this to the Manny animation blueprint. I'm going to go ahead and search for that. I'm going to duplicate this. And I'm going to call this APB Manny Motion Match. And that is the one that I want to plug in now to our animation blueprint. So we have our animation motion match. I'm going to compile and save all of this and press play just to make sure we're still there. Okay, so we have Manny running around with the standard old school animation blueprint. We have one more thing that we need to add to our character. Remember, we have the pose search database, we have the pose search schema, so we know how to look things up, but we need the trajectory. We need where do we get the information from to even provide the information for the lookup, and that's where that trajectory plugin comes in, and we need to add a component called a trajectory component to our character. So we add this to our character, we just call it character trajectory, that's fine. And we have everything we need to go into our animation blueprint to start setting up motion matching method 1, which is the kitchen sink, all motion matching all the time. So that's what we're going to do. Let's get it and hop into our animation blueprint and start setting that stuff up. But the setup is done. We're ready. Let's go. All right, let's get into the fun stuff. We are going to be taking a look at our animation blueprint now, and what we're going to do is we're going to basically throw in the motion matching kitchen sink. So let's go through this. This is the standard third-person animation blueprint. What we're going to be working in primarily is in our anim graph. And if we take a look at our anim graph, what we're going to do is we're basically going to replace this locomotion state machine with a motion matching pose search. So there's a couple things that we need to do in order for this to work. It's probably easiest to just kind of lay it out, and let's start adding in the pieces we need. We know we need a database. So how do we do that? Let's go ahead and type in pose search. And here we're going to choose this motion matching. Now, when you pick motion matching, you may accidentally get the larger version of this, which is just got all kinds of extra stuff in here. We're not going to worry about that one. We're working with the simplest, most straight ahead version of this motion matching stuff. So we have a motion matching, and you'll notice that we have a database. So in here, let's just go ahead and pick our database. In this case, we have Manny all. So in order to plug this in, there's a couple of things that we need. So first we need, if we just plug this in, let's just go ahead and do it so you all can see it. If we plug this in and we go ahead and we play, you'll notice that our character just kind of moves around but doesn't actually run. And that's because we haven't actually given the system the information it needs in order to track to basically be able to have the trajectory and the information. So what we're going to do after this motion matching is we're going to add in a pose history node. And you'll notice under pose search, pose history, the piece that is important about this pose history is we can actually plug in a trajectory, but we don't actually have a trajectory yet. So the other thing I want to call out is if you happen to watch the first version, the motion matching first look, we had these pose history nodes all over the place. We do not need that. We're just plugging in the one, and that will take care of even the second the method 2 and 3 that we're going to be doing in a minute. So I just want to call that out as a big change since the first version. So we basically have our pose history node. We do need to plug in a trajectory. How do we get it? What we're going to do is in our event graph, we're going to bring up our event graph, and on begin play, we've tried this before and a lot of tutorials have tried this and it has not been totally successful. So let me show you how and why we can do this now. Okay, so first off, what we're going to do is we're going to change our cast. We're going to change this cast to be our third person character. And the reason we're going to do this is so that we know that we can get our trajectory component. Now, a couple quick things on the cast. First off, I'm not worried about this cast. The third person character has to be loaded. It is our top level character, so it's already loaded. I'm not worried about performance for those of you that are performance inclined. Also, for the purposes of the demo, all we're trying to do here is get this trajectory component. There is you may find for your own work that there's a better way to get this. You can push it from the character, all kinds of stuff. But what I want to show you here is if we drag off of this, we can get our trajectory. So let's get our trajectory, and I am going to promote this to a variable. Promote to variable. And now that we have that as a variable, let's compile and save this. When we go back to our locomotion, and not our locomotion, we'll go back to our anim graph. What we can do is we can basically choose this pose history node, and over here on the right is a pen for the trajectory. Now I'm actually going to move this over so you all can see this a little better. If I click on this pen, I can choose to bind it, in this case, to the trajectory I just created as part of the anim blueprint. I don't have to do anything else. I'm just going to plug that in. Okay, so let's redock everything. And we have our trajectory being fed in. However, when we compile and save this and we play, our character doesn't move yet. None of our poses are updated. Why not? So here's what's actually happening. And we ran into this problem before, and we basically solved this a different way. But what I want to show you here is basically what is happening is this trajectory is not valid yet. It hasn't been initialized. And one way we can prove this to ourselves very quickly is let's just add in a delay here. If we just put in a quick little delay, 0.2 seconds, we compile and we save that. When we press play, all of a sudden our character is running now. And without geeking out too much, it's actually doing a pretty good job, which is great. So it's picking poses, characters running, stopping, doing all of the things. But let's not get lost in the excitement that motion matching is working. Let's just go back here. So what this means is it's an initialization problem. Our character trajectory is not actually valid yet. Now I'm going to keep this here because maybe depending on load times, etc., that might be the case. And what I'm going to do is I'm actually going to extend this down in our anim update, and I am going to add in a check to see if our trajectory is valid. So here's what we'll do. I am going to get the trajectory, and I'm going to right click this, and I'm going to convert it to a validated get. And what we're going to do is if it is valid, I am just going to go about the usual course of action. And if it's not valid, then I'm going to go ahead and do this over again. Okay, now there's a bunch of stuff I could do here. You know, rather than storing the character, I could store the third person character, then I wouldn't have to cast again, etc. Again, purpose of the demo, just to understand. The core concept here is the trajectory node is not valid yet. We need to double check, make sure that it is valid. If it's not, we need to actually go through the process of making sure we get it again. So here we go, we'll come in here. Now, in a normal game setup, you would wait till the experience is ready. You would wait till the character's loaded. There's all kinds of asynchronous loading stuff that you might do. But for the purpose of the demo, you get the idea. So we're going to ensure that this is valid. We're going to go ahead and get our trajectory component from the owning actor being cast at third person. We're going to set our trajectory and feed this in. So now what's going to happen is every time it comes in here, if this component is invalid, it's going to try again and then continue on. And eventually, after, it could be a tick, it could be 0.1 seconds, who knows how long it is. You can see I removed that delay. And if we go ahead and we press play, now all of a sudden we have our movement. That's pretty cool. And the great thing is, now we can geek out about motion matching. Okay, if I move forward very slowly, we even have our walks. You can see it transitioning between our walks and our runs and doing all of that stuff. Jumping still works because what's happening is our motion matching is actually feeding into locomotion, and in our main state you'll notice that locomotion is part of our normal jump, land, etc. So that's why all of our jumps and everything still work. Now, let's make a couple of changes so that we can better visualize and debug what's happening in this. I'm going to go ahead and change my orient rotation to movement, because I want to set this up more in the way that these Lyra animations were authored for, which was more of a strafing. It's more of something that looks like this. So the cool thing is we've got our pivots. I'm not doing anything. I've done no setup. I've done no, we basically have no blend spaces. I'm not tracking any variables. I'm not checking vectors on directions. I'm literally feeding the database the trajectory, and it is going in and choosing the right pose based on what I'm doing. So if I turn or move directions too fast, it's actually choosing which animation to play. It's actually doing a really good job out of the box. It's pretty quick. Now, one of the things that we can do to visualize this is in our motion matching database, we have a blend time over here. And there's a bunch of options that you can play with here as far as play rates and blend times, etc. Basically, as you work with motion matching, I would encourage you to explore what these different options do, how they affect your animations and playback. But the one I want to show you specifically right now is this blend time is the blend time within the database, within the pose search database, within motion matching. If we turn it off, it's a cool thing that shows you where the poses are being selected. So when I switch, you see this popping. Everywhere you see that crazy pop, what's happening is it is switching to a new animation, a new selection within the pose database. And so what we're doing with this blend time, if we change this to like 0.3 for example, is we're basically easing the transitions between those, so we get this nice kind of like start and stop, etc. That actually might be too much, because we're covering up our switch from out of our other state. So let's try 0.15 just to see what that looks like. Let's see how far we can push that. Yep. So depending on how far you push that blending is going to change how all of that motion works. But literally that's it. That is, if you take a look at this database, this pose search database, the stuff that we have in here is basically everything. This is all the walks, all the jogs, everything. We didn't do, I mean, it's awesome. All I can say is it's awesome, okay? So that is method one. And we're calling that the kitchen sink, all motion matching all the time, whatever you want to call it. Big things to note there is, in general, you need your pose history and the trajectory so it knows which poses to look up, and your pose search database. So now that we have method one, let's go ahead and label this as method one. This is going to be method one, all motion match all the time. Okay, so now that we have that, what we are going to do is we are going to take a look at method two. Now, method two, what we're going to do is we are actually going to set up a traditional state machine. And we're going to do that because I want to show you that basically we can still use motion matching even within a traditional state machine. And it's actually kind of cool, some of the additional controls you get as a result of doing that. So we're going to set up a very simple state machine, and then we're going to compare the two. So let's take a look at what that looks like now. Okay, for method two, we need a new state machine. So let's just go ahead and make a state machine. And we are going to call this motion match locomotion. Just so that we can keep them separate, and we know. And we'll go in here And we're going to set this up as a very basic state machine. So we're going to have our idle stop, and we're going to have run. That's it. So let's add a state, and this is going to be run. And the reason I want to keep this simple is I want to try as best as possible to compare apples to apples. And then I am going to add an alias, and this is going to be our toIdle alias. And this is going to plug in here. If you are not familiar with state machines and aliases and all these kinds of things and transition rules, there's an intro and blueprint tutorial on that. But basically this alias allows me to get back to stop from anywhere. So in this case, I want to be able to get there from run. Okay, so we need to control a couple of things. So first off, when we're in idle stop, we want to actually play just idle animations. And when we're in run, we want to play just run animations. So we need, and what we're going to do in here is we're basically going to put in our pose search motion matching lookups here. But to do that, we need two databases. So let's go back to our databases. We're going to take Manny all, and I'm going to duplicate this. And this is going to be Manny idle. And then I'm going to duplicate it again, and this is going to be Manny run. All right, and then our run, we're going to keep this very simple. We're going to get rid of idle. So let's save that. And then in our idle, we're going to get rid of everything else. We probably don't even need the rest of this stuff at all, but the whole point is you can do this. So there's, the idea of a pose search database with one pose in it, not so sure about, but it's good for the explanation. All right, so now that we have that, in our idle stop, all we need to do is plug in our pose search. So here's our motion matching. And in the idle, the one we want is Manny idle. I'm going to copy this so I don't have to redo it. And in our run, we want the run. So this is going to be our run, and we're going to plug this in. Okay. Now, what we need to do is we need to control our transitions. The way we're going to do that is if we should move, we're going to run, and if we should not move, we're going to go back to idle. This works because as part of the default, if you're new to all this, as part of the default third-person character template project, they were kind enough to set up a bunch of information and state variables for us. So we have ground speed, and we have should move and is falling, for example. So for us, what we're going to use here in our transition rule, we're just going to get should move, and we'll plug that in. So if we should move, then the character is going to run. And then if we're running and we should not move, then we're going to go back to idle. So let's get should. And remember what I said, if we should not move, so that means we're going to flip this. We're going to use a not, which flips this. Then we're going to go back to idle. Okay, so compile and save. Let's just save all just in case. So we've now successfully set up our state machine, so we can go from idle to run to and back, etc. And if we go back to our anim graph, what we want to do is we want to plug this in. So what I'm going to do is I am going to duplicate this, and we're going to plug this into our pose history. Now, I'm going to disconnect. Technically speaking, I only need one of these. So keep in mind, I'm disconnecting the other one, right? This is no longer being used. So this is just here as a comment for reference for when I upload these files to Patreon and so on. So here we go. So now we have our motion matching that is going through our pose history, which is now updating our locomotion. So let's see what this animation looks like. Okay, first off, does our character move? Oh yeah, character moves. Actually, the character moves really well. Do we have our, we have our jukes? Yes, we have our pivots, basically is what they're called. Now, one of the things that I want to point out as part of this is, look at what happens when I stop. Character stops on a dime. I mean, it comes to a stop within the square that the character is standing on. Let's look at that compared to what we were doing before. So if our character's running and goes to stop, do you see how the feet overshoot and come back? That's because the database is trying to pick the best pose based on trajectory. There is probably tuning that we would need to do with either the poses we have in the database, the pose selection, some of our prioritization. You can set the weighting of how important is idle versus run, and you can set all those variables and values in there. So there's definitely some tweaking we could do to make this, but you can see we've got a little bit of an overstep if we're just using the all motion matching all of the time if it's not properly tuned. But when we switch back to our state machine version of it, oh, that is pretty smooth. I think that feels really good. And actually, as a result of that, it feels so good that I can almost see using motion matching instead of blend spaces in a controlled environment. Because imagine this: you do forward run, backward run, left and right run, set up your blend spaces, and then you realize you need a little more fidelity. So you do forward left, forward right, back left, back right. Then you have to go back to your blend space, you have to reset up your variables, you have to track all that stuff. Not with motion matching. All you have to do is drop those in your run database and it just is going to find them, which is pretty cool, as long as they're authored right. Keep in mind, there's a lot of work to be done with authoring and everything like that, but that's kind of where my mind's going. Where can we, even if we're not using all of motion matching, I still think there's a lot of really cool wins in here where we can still have and create awesome art and save tons of time in implementation and use some of these tools, etc. Okay, so we basically now have two different methods of setting up motion matching. So let's go ahead and comment this. This is going to be method 2, and this is going to be our state machine match. Okay, so let's talk about method 3. What we're going to do with method 3 is we're going to basically rebuild the state machine version, but we're going to do it with a chooser table. And if you've never used a chooser table, the plugin I believe is also experimental, but it's really cool and it's probably best illustrated through example. So let's just go ahead and go through it, and then once you've seen all 3 of these methods, you'll be able to kind of take that and apply it as fits best for your project. So let's take a look at method 3 now. Okay, so for method 3, what we want to do is we're going to do the same thing. We have our pose history and we're going to choose a source. However, what we want to do is we are wanting to basically dynamically change which database is chosen based on some of our variables. In this case, we're going to keep it simple for this one. We're going to use the should move. So how do we basically turn this database into a variable? So what I'm going to do is I'm going to right click on this and I'm going to promote that to a variable. Now, all we need to do is effectively set this variable. So that's where the chooser table comes in. So let's go ahead and come back to our tutorial folder. And what we are going to create is a new chooser. So if we type in here chooser table, I'm going to call this chooser table Manny Loco motion match, or let's just do Manny motion match, for example. Okay, and then what we're going to do when we open this up, the way this works is you have to give the table information about what kind of table it is, what kind of assets does it store, and what does it use to select the assets that it has. So what we have over here on the right is we have our context data and our output. Now, our output is what we want the table to choose. So in this case, what we want the table to choose for us is a pose search database. So for us, we'll just go ahead and select pose search database, and we can go ahead with the object result. We don't want the class, we want the actual object because we're going to pick a specific database. And then the input is what is used to determine which of the databases we are going to generate or give as an output. So the easiest thing to do here is when we go ahead and add a context data, oops, I accidentally added 2. We're going to choose in here a class, and the class we're going to pick in this case is what are we using to determine which database we want. In this case, we're going to be using information from our animation blueprint. Should we move? How fast are we moving? What's our ground speed, move speed, all those kinds of things. So the class that we're going to choose here is going to be our motion match Manny ABP. So here's our animation blueprint Manny motion match. And so we have our class and we have our context. Let's go ahead and save this. And what you'll find is now that we've defined it, it knows what it's using to look for the object, and it knows what kind of object it's returning now. So over here on the left, we can now add rows. So if I add a row, I'm going to choose an asset. Once I do that, because I specified it's a pose search database, you'll notice that the only options I have are pose search databases. So I know I need idle, and then we're going to add another one. So let's add another row. This is going to be an asset, and I'm going to choose our run, because remember, we're recreating that idle run state machine, but we're going to do it with a chooser instead. So now that we have two options for this chooser table to return, what we could now, not what we could do, what we need to do is we need to add in the selection criteria under this column. So if we choose Boolean column, and the binding is going to, once we choose a Boolean column, the binding will come up. This is, notice it's picking our ABP Manny, and it's already found our options for which kind of Booleans. In this particular case, we're going to use should move. So now, once we have set this, these are the values that will determine whether or not we get idle or run. So if should move is true, we want it to be run. So that is true, okay? If should move is false, we want it to return our idle. So what's going to happen is, and you basically have three options here. You have true, false, or any. So if you want it, there may be some more complicated scenarios, etc. But one of the other things you'll notice is you can actually have in here, in addition to Boolean columns, you can choose based on enum. So for example, what is your current movement state? Are you flying? Whatever, that might be a cool one to use. The other one is float in range. So maybe, for example, you have a separate walk transition table or pose search database. And your walk happens when your movement speed is greater than 3 but less than 300, as an example. You might use that there. But anyways, so we've defined our chooser table, and at this point, we're almost there. So all we need to do in our event graph is we need to, on update, basically we're in our animation update, okay? We're going to add a pen, and I want to set this database. And the value that I want to set it to is going to come from the chooser table. So let's get the chooser table. So we're going to evaluate a chooser, and we're going to feed that into here. And the chooser that we're going to evaluate is the one we just made. We only have one. This makes this easy. This is our chooser table motion. And what we're going to do is we're going to take the result of this, which we know is a pose search database, so I'm able to plug it in here and plug it in. Okay. So what's going to happen is on animation update, it's going to evaluate whether or not we should move or not, and then the chooser is going to give us back whether or not we should be using the idle database or the run database, which is great. So now that we have that connected, let's double check our anim graph. So this is our method 3. Let's go ahead and comment this. For some reason, it's not letting me comment, so we'll just go ahead and plug in the locomotion. Let's compile and save all of this. And let's see how method 3 works. So, does it work? Yes, we can definitely run. We can definitely go right and left. We have our pivots, which is cool. And when we stop, interesting. Look at that. When we stop, there is definitely a little bit of either blending time or something that's going on with stopping. And one of the things that I wanted to show you about this, and it's particularly bad when I'm going to the left, right? It's still running for quite some time. Whereas to the right, it stops relatively reasonably quick. So why is this happening? Let's take a look at something in our animation. That is going to be, if we take a look at our PSD run, and we look at, I believe it's our pivots, and we look at jog left pivot. Oh, I didn't mean to double click that. I meant to single click that. Let's look at our jog left pivot. Okay, see the character runs and then stops. Okay, now let's look at jog pivot right. Whoa, character keeps running. Look at the difference between these two. One stops and one keeps going. So my suspicion is that because these assets have not been authored to be the same, it is potentially causing a little bit of confusion in the system, combined with some blend settings. Ideally, when we do this, we would want these to be roughly the same. Like, that's the whole point of having left and right. So the idea when you look at this animation, this one is 100. This one's over 100 frames long. If we go back and we look at the other side, this one's only 60 frames long. So it makes sense that on one side, it is sticking with the animation a lot longer than on the other side, just because of the difference in the blend times. Now, there's some other things that are also potentially happening in here, as far as the prioritization, or even the blending. Let's see here, if we go back here, we have our database, our motion matching, and our pose history. So there is, if we take and we drop our motion matching blend time down to 0, I want to see what happens here. Yeah, we get that popping back, but we still have the character running. So this is not an internal pose search blending time issue. Okay, and this may be a case where maybe the pose search normalization would help, things like that. But overall, the point here, or the awesome part of this is method 3. And this is going to be the chooser. And basically between these 3 methods, I love method 1 for quick and easy and fast setup. Get a bunch of stuff in, test it on a character. It's pretty awesome. I like method 2 for the control. I think method 3 is awesome because learning about choosers is amazing. It's a powerful tool that we can potentially use in our animation blueprinting and all kinds of other stuff. I mean, think about choosers, or even motion matching for corrective animations and additive animations, all kinds of stuff. Like your brain's like running a mile a minute. But so each of these has a different win to it, something awesome about it. My favorite is probably the state machine, largely because I probably come from a state machine world, but I don't want to discount how awesome and fast this kitchen sink is. But I love the control personally of method 2. In some of my own personal work, this is probably going to be the method that I am going to be exploring and extending. So we did it. Motion matching first look, round 2, so probably second look. But this was actually, I think, a more succinct and better presentation of motion matching. The 3 different methods are really cool. So hopefully there is something in one of those workflows that will help you in your own endeavors. At the very least, we tackled a couple of the common setup problems step by step, which you can follow along for your own projects and take care of. Before we wrap up our motion matching video for today, just one more huge shout out to Andre. His LinkedIn is going to be down in the comments down below, as well as if you like what we're doing here, there are lots of ways to support the channel. We have the tips down below, we have the Patreon, we have hopping in. If you just have a lot of knowledge on any particular topic, you're an expert in your field, hop in Discord, help answer questions. That's awesome. The community is really great about helping each other out, as well as, and as always, spreading the word is awesome. So with that, my name's Kevin. Thanks for checking out the video, and I hope to see you in an upcoming live stream. Take it easy.